We have now finished discussing the fundamentals of building automation. These lessons are important to our subsequent discussion because it covers the basics. Without them, we cannot create an automation and we wouldn't know where to begin. Last time we talked about field devices like sensors and actuators. Now we will install them on a field system. So let's move on to the course's most interesting part, the development of building automation. Okay, so this is a simple AHU construction that supplies fresh air to a certain space or room. Air handling deals with filtering the indoor air with an air filter. This is the air handling unit from which filtered air is supplied. The temperature of this purified clean air is then adjusted to make it more or less comfortable. To enhance air quality, a portion of the inside air is also partially replaced by new outdoor air during this procedure. Thus, the air from the room will return to the AHU and be replaced with fresh air. That is a brief summary of how an AHU works. With a BMS, we may improve it in the simplest way possible. Let's study the operation of the AHU in more detail. By knowing the system's flow, it will help you decide where to place a sensor or device. So the unit takes air from the outside and then filter it in this area. The pre-filter or aluminum filter and bag filter compartment. Dust and debris from the air are captured by air filters. After filtering, the air will recondition by cooling coil or heating coil. The supply fan will then take the clean air and direct it into the room or space. And from the room, the air returned to AHU and return fan will take it inside the unit and mix it with fresh air. So that was the AHU functioning cycle. The cooling process of an AHU is done by a chilled water. So we have here a chilled water supply going to the cooling coil, and then chilled water will exit here and return to the chiller system. In order to choose the sensors to be used for an AHU system, let's first go over a list of sensors and devices that we can integrate with the AHU system. This is Siemens QFM 2160 duct sensor for humidity and temperature. A control sensor for the supply or extract air, meaning we can use it for supply air duct and return air duct. The sensor acquires the temperature and humidity in the air duct via its sensing element, whose electrical resistance changes as a function of the temperature and relative humidity. This type of sensor changes in resistance is converted to an active 0 to 10 volts DC output signal corresponding to a temperature range of 0 to 50 degrees centigrade and 0 to 100% relative humidity. The duct sensor consists of a housing, a printed circuit board, connection terminals, a mounting flange, and an immersion rod having a measuring tip. Next is a Siemens differential pressure switch QBM81 series. It is used for ventilation and air conditioning plants to monitor air filters, airflow, and recognize turn fan belts. There are 5 types of QBM81 differential pressure switch. Each type have a specific pressure range. We can use this one for monitoring filter and as an airflow switch. The differential pressure between the two pressure connections deflects a spring-loaded diaphragm. This special diaphragm ensures the long-term stability of switching points. Each type is engraved with individual scales for very precise adjustment. It has a 3-port switching terminal labeled as 1, 2, and 3. 1 and 2 terminal is normally close contact, and 1 and 3 terminal is normally open contact. This one is differential pressure sensor with operating voltage of AC 24 volts and an output signal of 0 to 10 volts DC. The differential pressure sensor acquires differential over and under pressure of air and non-aggressive gases. If a high degree of measuring accuracy and quality is required. It is also used for measuring volume flow via differential pressure, since the output signal can be set to extracting the root. It can measure the slightest differential pressures in ventilation and air conditioning ducts. The sensor acquires the differential pressure using a silicone rubber membrane and ceramic bar. Depending on the type of sensor, the sensor generates a linear or extracting the root signal 0 to 10 volts DC. This is QBM 62.1 air velocity sensor, used to control the air velocity to a constant value, or to balance out pressure fluctuations, or to monitor the flow in the air ducts. The QBM 62.1 records the air velocity as a measured value and converts it to an active DC 0 to 10 volts or 4 to 20 milliamp output signal. 3 measuring ranges are available: 0 to 5, 0 to 10, and 0 to 15 milliseconds. The specially developed thin film sensing element of the QBM 62.1 is to a big extent independent from the flow direction and is nearly insensitive to any kind of dirt in the airflow. SQX62 actuator is a 24 volts AC operating voltage and have 3 positioning signal: 0 to 10 volts, 4 to 20 milliamp, and 0 to 1000 ohms. The recorded positioning signals control the synchronous motor by means of microprocessor electronics. This motor generates the desired stroke via a blocking proof gear train and gear rack. The motor has a protective function, effectively prevents a thermal overload of the synchron motors in swinging control circuits or highly dynamic control. Okay, now let's enumerate the tasks that require a monitoring device or a sensor in accordance with the components of the AHU system. Number 1, we need to monitor the filter status. If filter gets dirty, an alarm will energize as block filter alarm. 2, butterfly valve for chilled water supply should be motorized and have an automatic function. 3, we need to monitor the supply air and return air temperature, humidity, pressure, and velocity. 4, we have to install airflow status for supply fan and return fan. 5, damper actuators should be installed in supply air damper, return air damper, and fresh air damper. And number 6, supply fan and return fan status. Okay, that will be our task to be completed for the HU system. We will go through each task in detail during our upcoming lesson, so stick around and see you then.